Hello everyone, today I want to maybe cure a common misconception about helicopters, or maybe just make an interesting little experiment and tell you a little bit about helicopters. I don't know if this is still a common misconception. It was called a common misconception when I was a young kid first learning about how helicopters work. I've kind of lost touch with common misconceptions about helicopters, but the misconception is that the tips of a helicopter rotor blade supposedly break the sound barrier and go faster than the speed of sound, which is simply not true. This is often used as a attempted explanation of for the sound that helicopters make, especially the frequent low beating sound. That's supposedly the rotor blades breaking the sound barrier and then going below the speed of sounds again and again, and then you get a lot of sonic booms. That's not what actually happens. What actually happens is just that the rotor mechanism interacts with aerodynamically interacts with the fuselage of the helicopter, and any movement, especially when a helicopter moves fast, then the blade that's currently moving forward is overall moving faster than the blade that's currently moving on the backward side of the helicopter. So it gets more lift and moves slightly upward, since every object is slightly elastic, and they're actually designed to be slightly elastic so they don't break. And the blade on the reversing side is going slightly downwards, and that together with other effects creates a kind of beating sound. Now for the more fun part, I thought we'd try to find out the what's actually a more common rotation speed. Now, interestingly, the RPM of a helicopter rotor is, of course, it can be found out, but it's not that easy. Like most Wikipedia pages about helicopter types don't have a rotor RPM listed. There are, of course, ways to look it up. It's just not that easy. But then anyone can do that. So instead, I thought I'd put in some of my older videos from ELA Air Show, which I made in slow motion, and where you can actually see helicopter rotors of different helicopter types rotate. And these are in 1/8 slow motion, but I slowed them even farther down to 1/16, which does create a little bit of low frame rate effect, but it's quite followable for the human eye now. And I actually did some frame counting and basically indicated the speed, and I ran the calculations for the NH90. And of course, you can look that up for many helicopters, and obviously there are a few slight differences, but in general, it's roughly similar between all helicopter types. Usually, bigger helicopters have a slower rotating rotor in terms of rounds per minute, but the blade tip speed is usually relatively similar between different helicopter types. But, well, as you see, it's usually around Mach 0.6, Mach 0.7, around two-thirds the speed of sound, depending on helicopter type and depending on flight situation. Though the rotation speed of the rotor doesn't change that much, it does change a little bit. It's not actually supposed to change, but it's just impossible to perfectly regulate a system like that. So it changes slightly, but in general, it's not supersonic. And even if you add the speed of the fastest helicopter, which is, in terms of conventional helicopters, actually not the Hind, but a slightly modified version of the Hind that is a little bit faster than the normal Hind at roughly 100 meters per second. And if you actually add that to the tip speed of the Hind, you're still a little bit below the speed of sound, and that's already a really extreme speed for a helicopter blade. Most go way slower, so it actually only the sound actually only comes from the helicopter rotor basically vibrating as it goes through its rotational cycle and encounters different fields of air, different fields of turbulences, interacts with the fuselage and the wind and the movement of the helicopter. This, of course, also makes perfect sense if you look at the helicopter blades as wings, and of course, if you want an efficient flying wing, and it's not its purpose to fly at supersonic speeds like a supersonic airplane, but the speed doesn't actually matter that much, and you just want it to be effective and efficient, it makes sense to keep it subsonic. And also, if you run rough calculations of a very rough estimate of how much speed would actually be needed to keep the average helicopter in the air, and what's the average size of helicopter rotor and so on, you'll also come up with way subsonic speeds of about Mach 1/2. So I hope you kind of enjoyed the background footage, and maybe you found this interesting. I can go deeper into how helicopter rotors work. I can do different topics. I'm open to any suggestions. I'm still learning and hoping to improve myself, which is actually also why I don't use a script. I know that I could probably do better if I used a script, obviously, but I'm trying to learn and practice not using a script and improvising, so I can then make formats where using a script is just impossible and where editing is also difficult, and I'm kind of practicing for that. So I'm open for any suggestions or feedback, and thanks for watching.